Doug Bauer. I'm an assistant professor at Bucknell.
And I'm Tyler Anderson. I'm a senior at Bucknell University. Civil engineering student.
So, yeah, Tyler's a senior. He did a lot of great work for me this summer. My research area is actually in highway safety, focusing mainly on car crashes and runoff road crashes. So I do a lot of work with roadside safety barriers, guardrails, median barriers, things of that nature. So Tyler helped me out with that this summer. He's done a great job, and hopefully you guys will enjoy his talk and have a lot of new questions for him. So I'm looking forward to it. So without further ado, I'll turn it over to Tyler.
First off, I want to thank you guys, Michael Baker, for the funding to do this project. It was a real good learning experience for me this summer. I learned a lot, and it's definitely something that's going to help me in the future with whatever I end up doing. So I'd like to thank you guys a lot for that. And so the presentation, or my research that I did, was an investigation of rollover and vehicle-to-traffic barrier crashes. Mainly looked at the tripping mechanisms in crashes and what actually causes the vehicle to roll, as well as how the vehicle actually interacts with the barrier. So, here, our motivation for this study was quarter of all fatalities occurring in vehicle-to-traffic barrier crashes actually involve a rollover. So, rollover is an important aspect into whether or not someone is injured or killed in a crash. And as you can see here, this is a real crash taken from an NASCDS database where this Chevy Suburban impacted this longitudinal barrier, strong post W-beam barrier, and subsequently overrolled or overturned due to the impact. And so as you can see here, this is a real problem that exists on the roadways today. And we were not the first ones to look at this study of rollover and crashes involving longitudinal barriers. And so here's some other studies that have been previously done. But it's important to know a couple problems exist with these previous studies. As you can see here, the age of these studies is in most cases over 20 years old. So they don't represent the current vehicle fleet and or barrier designs that are out today. As well as over here, the location. Many of these studies were just done in specific states and may not represent the national data, not represent national crashes and stuff. So these studies also posed conflicting results, and they mainly only looked at the barrier type and what type of barriers involved, and not exactly what causes the vehicle to roll or the interactions the vehicle has with the barrier. So we approached this research with two basic questions or objectives. First, we examined the tripping mechanisms in these rollovers with vehicle barrier crashes. And second, we examined what influences a vehicle to roll, mainly how the vehicle interacts with the barrier, as well as whether multiple barrier impacts occur in the course over the series of events that occur in the collision. And as you can see down here, this is what we consider an ideal case for a barrier performance in one of these collisions. The vehicle comes along, impacts the barrier, and remains traveling its intended direction of travel without any spinning or anything. And this is how ideally the barrier is supposed to form. So our overall approach, first to this study, first we had to do our case selection and select our cases from our database, and then we had to code our cases by looking at each case individually and looking at more of the barrier information using scene diagrams and photos, because that database we used focused primarily on the vehicle and not actually the barrier. And so we were able to come up with our final data set, and then we had to characterize the data using simple statistics, and we were able to use a computer just to get a general layout of the trends and stuff we were looking at within our data set. And then we developed two different statistical models be able to analyze what the factors that actually influence whether a vehicle rolls or not. And so this is NASCDS database. Is the database we used and got all our data for this study. It includes approximately 5,000 cases per year nationally of just all vehicle crashes. And to make this data nationally representative, it uses weight estimates that are developed using just different statistical methods. And as long as you use these weight estimates in your analysis, this data is nationally representative. And this data set includes passenger cars, light trucks, and vans. And it excludes heavy vehicles like tractor trailers and stuff like that. To be included in this data set, the vehicle must be towed due to damage. So this data set doesn't include any of the minor crashes that may occur where the vehicle can just drive away. And this data set, it's got a high level of detail compared to data from a simple police report. Could have probably only about 100 different data characteristics in it, while this has over 500. As you can see up here, this is a picture taken from the database, and you can see them. They're measuring the deflection right here of the impact on the front end of the vehicle. So you see they take a bunch of measurements at the crash site and afterwards of the vehicle as well. And our case selection criteria we used to select our cases was we took 12 years from this data set, ranging from 1997 to 2008, and this was primarily because before that you start getting into older vehicle models and stuff that may not represent the current fleet, as well as there was no pictures in the data set that we could use for our analysis prior to 1997. So, and the cases we selected had to be where the barrier was the first impact in the series of events that occurred during the collision. So our cases fell into primarily these 4 categories. One was the vehicle impacts the barrier and simply redirects off the barrier. Second, vehicle impacts the barrier and subsequently rolls through the impact of the barrier. And then over here, the vehicle impacts the barrier, redirects off the barrier, and either impacts another barrier or could impact another fixed object like a utility pole, embankment, curb, or something of that nature. And then over here, we got the vehicle impacts the barrier, redirects off the barrier, and then impacts either the same barrier again or another fixed object and subsequently rolls due to that second impact. And so each of these cases had to be manually coded because of the NASCDS database didn't include all the characteristics that we were looking for the study. So first off, we coded for barrier type. The database does code for barrier type, but it also has pictures of the barriers as well. And so we went through all the cases and made sure that they were coded properly, because sometimes it coded for a barrier that wasn't actually a barrier and that wasn't actually meant to redirect the vehicle, like a curb or a planter or something of that nature could have been coded as a barrier even though it wasn't. So we made sure all those were correct. And then we coded for vehicle to barrier interaction using a scene diagram like shown here. This was just how the vehicle interacts with the barrier and what type of trajectory it redirects off the barrier at. And then we coded for impact angle, just what angle the vehicle impacts the barrier at, and then barrier impacts, whether it was a single barrier impact or multiple barrier impacts. So barrier type. These were 5 main, pretty much the majority of the cases all fell in these 5 categories. We have strong post W-beam barriers, weak post W-beam barriers, cable barriers, box beam barriers, and our typical New Jersey style concrete barrier. And we separated these into two primary categories. We got our metal barriers over here, and then we have our concrete barriers over here, which is just primarily this New Jersey shaped barrier.